Let's apply all that you have learned into answering this problem. I highly suggest you pause the video and try to answer this problem on your own. Resume the video once you have an answer and see if you and I have the same result. Alright, seawater contains 1.08 times 10 to the 3 parts per million of sodium ions. Calculate the molar concentration of sodium ions given that the average density of seawater is 1.02 grams per milliliter. Let's write down the given. We're given with 1.08 times 10 to the 3 parts per million, which is concentration of sodium ions. We're also given with the density of seawater, 1.02 grams per ml. I'll just call seawater as solution. We need to find the molar concentration of sodium ions, which is the moles of sodium ions per the liter of solution. Alright, so let's now start the solution. I think the simplest and easiest way to do this is to suppose we have 1,000 grams of seawater or solution. In that case, we have 1,000 grams times 1.02 grams per ml. Using my calculator, we have 980.3922 milliliters of seawater. I'm calculating for the volume of the seawater because I would need to divide the moles of sodium with the volume of the solution. So this is a good first step. We're done with the denominator. Let's now find the moles of sodium ions. To do that, we need to use the parts per million. We know that 1 parts per million is mass over mass times 10 to the 6. So if I divide parts per million by 10 to the 6, I would be left with mass of solute divided by mass of solution. So let me start with that. I have 1.08 times 10 to the 3 grams of solute per grams of solution, and this is divided by 10 to the 6. So I'm converting parts per million back into grams. Because I supposed I have 1,000 grams of solution, I could just multiply that to eliminate gram solution. And now I just need to convert grams of solute into moles of solute. I forgot to write it down, but 1 mole of sodium ion is equivalent to 22.99 grams. So we need to divide 22.99 grams to have 1 mole. Now, this is in terms of moles of sodium ions. We now need to divide everything by the liters of solution, which is 980.3922 ml, multiplied with the conversion factor of 1,000 ml to 1 liter. Notice that I am using 4 decimal places in my volume measurement. I did not reduce the significant figures yet because it is an intermediate calculation, and if I rounded it off, I would encounter rounding off errors. The final answer should be 4.79 times 10 to the negative 2 molars. Notice that the concentration is expressed in three significant figures corresponding with the provided values in the given. I really want you to practice having solutions that can be inputted once in a calculator. In my current calculation, I had to calculate for the volume separately, which allowed me to round off the values. Ideally, I don't round anything off and let the calculator do everything for me. I should only round off during the final value. So what do I mean by that? Let me show you an alternative solution. I know that I need moles per liter, so I'll take my value that could lead to moles at the numerator and the value leading to volume at the denominator. So for 1000 grams of solution, let me start with 1.08 times 10 to the 3 milligrams of solute per kilogram of solution. To eliminate solution, I multiply it with my supposed value, which is 1 kilogram. Cancelled out. I know that for 1 millimole of sodium ions, I have 22.99 milligrams of sodium ions. Again, this conversion to the milliscale is valid because I'm just applying the same factor to both the numerator and denominator. And I'll just convert this to moles. Again, 1000 millimoles for 1 mole. Then I divide everything by 1000 grams of solution, but I know that there are 1.02 grams per ml of solution. And since I want this to be in liters, I just divide this by 1000 ml. And here I have a solution that has only one line or one step. I highly recommend you train yourself to have a solution like this so that you won't need to break down your solution into steps and have to round off. In this case, it is much easier to input in the calculator and it's much easier to track the cancellation of the units. So once more, the value is 4.79 times 10 to the negative 2 molar, which is just the same as a while ago. I hope this was a good refresher for you with moles and concentrations, and I'll see you in the next video.